Okay, so today we're going to go over basically a bit of review of what we went over in the class today. So basically this video will be a way to supplement what we went over in class, and hopefully if you were confused on anything in class, this will clear some stuff up. Okay, so we're going to go through all of these exercises that I've laid out here. So right now I'm in a script window just so I can already type all of this out. But you can do this in the command window as well if you want, on a individual exercise basis. So we're going to start with this first exercise here. We're going to make two row vectors, and then from those two row vectors we're going to make a new row vector. So we're going to append a row vector. So I'm going to do x1 equals, we'll do some row vector here, we'll do 20, 32, and negative 2. Okay, I'm going to suppress the output. Then I'll do x2 equals, we'll do x2, okay. 2, 3, 90, minus 34, 20, 80, or 90, okay. So there's another row vector. So now from these two row vectors, I want to make a new row vector that consists of those two row vectors that we have right now. So we'll call this, we'll use I don't want to use big X, we'll do Y. So we'll call it Y1. So Y1 will be consisting of X1 and X2. So I'll do X1, then I'll do a comma and X2. So I'm making a new row vector Y1. It's going to start out with this row vector x1 up here, and then being appended to that row vector is x2. So I'm going to run this right now. It's going to ask me to save this file. Sure, I'll just save it in here. Alright. And now, let me pull up the command window here, and I'm going to kind of tuck this away. I don't think we're going to look at the slides here. So now if I type out, we'll do x1 first, and then we'll do x2. Then if I type out y1, then you see that y1, it starts out with this row vector x1. So we have 20, 32, and negative 2. And then I appended the row vector x2 to x1. So now we have 2, 3, 90, negative 34, 20, and 90. Alright, so that's how we can do some basic appending for row vectors. Now we'll do it for a column vector. Alright, I'm going to do x3 equals 2, 3, 4. We'll suppress it. Then x4 equals 5, 6, 7, 8. So the variables that I've been typing out so far, they don't matter. Let me make that x4. You can make them, whatever you want. I'm just trying to have one variable for each vector that I'm making here. Okay, then I will do y2. So let's say this time I want to make this new column vector y2. And I want to start out this column vector with the values that we have in x4. So I want to do y2, that's going to be a new column vector that's 5, 6, 7, 8. And then after that, 2, 3, 4. So to do that, we do x4. Then we're going to use a semicolon. So basically what we're doing is we have y2. You're going to give me the column vector of x4. Now we used a semicolon, so that says terminate this column vector now, and allow us to add a new column vector underneath. And then we're going to add in that column vector x3. So I'm going to run this, and you see I took out the semicolon, so I'm not suppressing this text output now, and that's going to show up in the command window. So we have y2, and we have 5, 6, 7, 8, and then 2, 3, 4. So it showed up exactly how we want it. Okay. So now we're going to do two row vectors to make a matrix. So we're going to define a matrix on one line here, and we're going to basically build this matrix from row vectors. So let's do I know, a 2 by 3. So we'll do A. Oh yeah, we'll do A. So we want to have 2 rows here. So I'll do, and we want to make it 2 by 3. So 2 rows and 3 columns. So we'll do 2, 3, 4. So that's 1 row right there with 3 columns. And 5, 6, 7. There's another row with 3 columns. If I run this now, then we see A down here is a 2 by 3. So you can almost think of this like we're appending our vectors in one line. So what I did is I defined a row vector, and then I'm appending a new row vector here, but I'm appending it below that first row vector. So that's why we get this output, 2, 3, 4 on top, and 5, 6, 7 on the bottom. So let's see. I could have also done 5, 6, 7 first, and then 2, 3, 4. So 5, 6, 7 would be up top. We'll do A1 equals 5, 6, 7, and 2, 3, 4. So I'm going to clear this here. Now if I run this, we see A is 2, 3, 4, and then 5, 6, 7, going by rows. And then A1 is 5, 6, 7, then 2, 3, 4. Alright, so we can also make a matrix from 2 or however many column vectors we want. So let's do that right here. Just do that, okay. So here we made a matrix by defining row vectors, but now we'll do it by doing a column vector. So first off, I'll show you what doesn't work. Okay, so we'll do B equals, so I'm going to use these same vectors here, but I'm going to make them column vectors now. So we'll do 2, 3, 4. So first of all, I'm just going to show you the output that we're going to get for B. If I run this, then we get 2, 3, 4. That's our column vector. So let's say we wanted to make a matrix by having this column vector here, and then we want to add the other column vector, 5, 6, 7, right here. So in a new column, basically. So if you're following the logic that we used for making a matrix with 2 row vectors, you would think, okay, so I can just put in a comma here, or a space, and I can write 5, 6, 7. So you think it's going to list out the first column vector, 2, 3, 4, in one column. And since we had a comma or a space, and then we put our other column vector, 5, 6, 7, that it would then put that column vector in a new column. But if we run this right now, it's not going to work. It says our dimensions of arrays being concatenated are not consistent. So we can't build it this way. So what we'll do instead is we need to wrap each column vector in its own brackets here. Excuse me. Alright, so now we've wrapped it in their own brackets. I'm going to add a line of code up here, just so I don't need to keep clearing everything by hand. Okay, do CLC. Alright, so now we're going to look at this output here for what we just wrote. And now we got what we wanted. So now we have 2, 3, and 4, and 5, 6, 7. I'm also going to unsuppress matrix A here. So here we defined a matrix that was a 2 by 3. So we have 2, 3, 4 up top here. That was our first row vector. And then the second row vector we had was 5, 6, 7. So this is a 2 by 3. And this one right here, matrix B, this is a 3 by 2. We have 3 columns, or sorry, 3 rows and 2 columns. Okay, so let's say we wanted to use column vectors to define the same vector A right here. So we can do that. We can do, let's write a new one here. So we're going to need 3 columns now. So we'll do 3 column vectors to make matrix A. Alright, so we'll do C. So again, we want to look at matrix A here. So now we're going to have basically 3 2x1 column vectors. So we'll do 2 semicolon 5. We can do a space, then 3 semicolon 6, and then a space, then 4 semicolon 7. I'm going to suppress this. And now once we run that, then now we have the same matrix here. So we have matrix A equals 2, 3, 4, 5, 6, 7, and matrix C is 2, 3, 4, 5, 6, 7. So it's the same matrix, but it's defined in different ways, or is built in a different way. Matrix A was built by using 2 row vectors. Matrix C was built by using 3 column vectors. Alright, we have a few more exercises here, so let me just add a lot of space. Alright, just so this is more in the center of the screen. Alright, so now we have 2 1x5 row vectors to make a 5x2 matrix, so let's do that. If you're starting to hear background noise, there's a leaf blower in the background, so hopefully it's not too bad. Alright, so we want to have 2 1x5 row vectors, so that just means 2 row vectors that have 5 columns. I'm going to do a lowercase a1 right now, so we'll do a1 equals 2, 3, 4, 5, 2. And we'll do a2 equals 0, 9, 8, 2, 3. So now what I want to do is I want to make a 5x2 matrix. So right now we have 2 row vectors and they're 1x5. So if we kind of look at this right now, we can kind of visualize if we were going to append these, or even just, look at this block right here. That looks like a matrix, but it's a 2x5 matrix. We want to make a 5x2 matrix, so we need to use the transpose operation. So let's call this D, and all we have to do is A1 transpose, and then A2 transpose. Now we can make that. Let's suppress some of this stuff. Run it again, and now we have a 5x2 matrix right there. And you also notice that I put a comma there because I want to have, basically I'm defining a row vector here, or sorry, a column vector after I've done that transpose operation that has made a column vector. Then I'm using a comma, and then I have my other column vector. So you might be thinking, why is this kind of working here? And it didn't work up here when we didn't have, brackets enclosing each column vector and then enclosing the whole thing. It's just because we have defined these column vectors to a variable. So if I was going to try to make this matrix D right now without having the variables A1 and A2, it wouldn't work. So I'll do E equals, so now I'm going to do the first column that we have, 2, 3, 4, 5, 2. Then we'll have a space, 0, 9, 8, 2, 3. And then if I ran that, now it's going to give us an error. It doesn't work. I can even put it in a comma, and it doesn't work. So it's just because we have to define these column vectors first to a variable, and then we could use this format right here. Okay, so now we're on the last exercise. So we have 2 3x1 column vectors, and we want to make a 2x3 matrix. So first what I'll do here is do E equals B1, comma B2, and we'll look at that output. So this is a 3x2 matrix, we want a 2x3 matrix. So how are we going to do that? Basically, instead of using a comma, what we want to do is use a semicolon. So if I just do this, what's going to happen? It's just going to make a, I thought I had a comma for a second. So it's just going to make a longer column vector for us. But we want to have a 2x3 matrix, so what we have to do is transpose both of those column vectors to a row vector. Now if we run it, then we get a 2x3 matrix. If I wanted to do, with these two column vectors here, b1 and b2, I could also do something like make a 1 by 6 row vector. So I can do that by b1, transpose it, then we're going to put a comma so I can append a new vector to this vector. So I'll do this, and now if I run this, then f equals this 1 by 6 row vector. Let's do b1, transpose, and then we're not going to transpose b2. Do you think this is going to run okay or not? It's not going to, because we have basically a row vector, and then we're trying to append this row vector with a column vector. So I kind of think we're going like this, a row vector, and then we're trying to add this column vector. That's not going to work. Those dimensions, they're not the same. We have a 1 by 3 row vector and then a 3 by 1 column vector. So that's not going to work. Alright, so anyways, that's all I wanted to cover. So hopefully this helped you out more so you can attack the homework better and then also be better prepared for the quiz. The quiz will have, other stuff like plotting and generating arrays. So that'll be like using the colon operator. So doing something like this. So this is going to create a row vector from 0 to 10 using a step size of 0.1. And then you could specify the length by doing length of x. And that's 101 elements. And that's because we're starting at 0, not 0.1. So we started at 0.1. And then we ran the length of x again. And then it's 100. So, and then we're also going to, use the linspace command. You should know how to use that. Know how to plot stuff. Know how to specify a variable in an array. So if we had this array here, I want to look at the 25th element, and I want to see the value for that. I do x of 25, and then we get 2.5. So anyways, kind of a tangent there at the end, but again, hopefully this helped you out. Email me if you have any questions, or go on the Discord. Alright, I'll see you guys on Wednesday.